Yeah, I'm Aran White. I work for Broadcom. Broadcom in the API space. Often I get asked, what the heck, who are you, what are you doing, don't you make chips? Hopefully the last few months you'll have known a bit more about Broadcom because we just acquired VMware. My background is I started working in the API space over 20 years ago. I worked for IBM for a long time, working with their data power solution, and then I moved to a company called Layer 7, and that's how I ended up being in Broadcom. So Layer 7 was an API gateway, API security solution, and that was acquired by CA Technologies, and then that was acquired by Broadcom. So that's my background. I've done a whole load of different jobs in that space, working with Layer 7, and now I'm head of product management. So from being in the field, I actually get to implement the things I wanted to do. But I wanted to talk about API security because we've been talking about API security for 20 plus years. But API security is suddenly a really hot topic. And when I talk to people like Gartner or Forrester about what is API management, what is API security, I think it's starting to get the focus it needs. But some of that is because of hype, because of all the vendors putting API security on their slides and on their products in the same way that people are putting AI and ML and that kind of stuff in. So there are lots of tools out there. There are lots of different approaches. There are definitely people that have come up this from the API gateway and API management space. There are people that have come from the testing area. And then there's what I would call the anomaly detection people, the people that have come into this from a different viewpoint, like Salt and No Name and Sequence and Traceable and all those other organizations that are out there. So we're going to look at some best practices. I don't think one of these solutions fits to solve all your security needs. So I think it's a multi-vendor, multi-solution way to solve your security. But I wanted to make sure we look at the basics because there are some really interesting new ways of doing anomaly detection and API discovery and things like that, but we should not forget the basics. So we should build from the ground up. The reason we need to do this, I'm sure you've got lots of brand new APIs that you're sharing. Should the clock have started? So it's all right. If I get all that time for free, I'm fine, yeah. So yeah, the new APIs that we create and build, they're great. Hopefully we're building security in from the start, but we have lots of other APIs we perhaps can't control. The amount of organizations I find have got an API and it's not been touched for 5, 10 years. Makes me feel old, but that's true. We've got third-party APIs, so APIs we're consuming are also very important. So I think it's important that we go back to the start and we make sure we do security right from the ground up. So we're going to look at 7 or 8 topics that we should consider as absolute defaults when we're putting APIs in place and the security around them. So the first one, hopefully is pretty obvious, but is transport. If we're using regular APIs, HTTP, we should be going with HTTPS. Unless you've got a very basic internal API, I think transport has to be secured. But turning on security is not enough, right? We need to tune it. We need to say which algorithms we're going to support. We need to say which versions we're going to turn off. There are lots of old versions of things like TLS, SSL. We need to tune those down. Sometimes we can't do that. Sometimes we've got clients that rely on us and the old technology. So, you need to think about how you deal with that. If a client connects with an old version of TLS or an old encryption standard, let's treat them differently. Let's divert their traffic. Let's ask for some step-up authentication and things like that. Final point on this slide is are you ready for post-quantum cryptography? I noticed that Apple have launched that into their iMessage. I think it's something we need to look at. So making sure you're pluggable and your crypto can be changed as it needs to be is going to be really important in the PQC world. Okay, so you've secured the transport, but then you need to support the user and secure the user. I thought the talk from Travis this morning on that identity idea and having credentials in a wallet was really interesting, and that kind of feeds into this. It used to be about a username and password. It's way more than that now. We're authenticating the user, the application. In many ways, we give the keys to the kingdom when we authenticate with Facebook or we authenticate with something else. So we need to think about how we look after the device and the application. We need to think about how we do things like MFA and step up, passwordless. I think passwordless is really interesting. And one of the real benefits of doing that is, A, you look more secure, but B, you actually reduce the things you have to do internally. A lot of what Travis was talking about actually reduces the infrastructure and reduces your vectors of attack. So I think that's really important. Access and ID tokens, there are lots of best practices. We need to look at that. We need to look at things like application keys and secrets being recycled and refreshed, not being left out there for years on a GitHub repo and exposed to the world. So making sure you know who's coming in. That can be multi-factor authentication. It can be different types of credentials for different people. But you need to make sure you're really authenticating the person, the application, and the device that's coming to use your API. Hiding and signing. Back in the day when I started using, probably pre-SOAP actually, XML services, B2B services, things were encrypted. We had things like XML signatures, XML encryption. And although they were a real pain in the backside to do, they made a lot of sense, especially in that B2B space. As we've removed the perimeter for APIs, we've got traffic going northwest, north-south, east-west, and in all other directions, it's becoming more and more important for us to think about encrypting and signing that data. It's not always a one-to-one relationship between the requester and the response. That traffic can be hopping around internally in your microservices environment, going from one place to the other. So we need to make sure we sign and encrypt those things so that only the right people can see the right data and that they know it came from the right source. This can be important in the API itself, but it can also be really important in the auditing and logging. Non-repudiation in logging and transactions can be very important. So this is one to think about, not just the APIs, but the other parts of your infrastructure as well. I nearly put this at the start because I think it's one of the most basic ways we can protect our APIs, but defining an API is really important. We used to have SOAP services and XML services, and things like XML schemas and SOAP definitions were very, very tight, very tightly coupled. We went into REST, and that was free form, and it was a bit like the Wild West for a while. We've now got some really good specifications, and these do a number of things. I always think of the first thing of a specification is it makes it easy for someone to consume my API. That's a real benefit of it. But it also helps us secure that API. If we know the type of message that's coming in, the structure of that, then we've got a way of deflecting or deterring incorrect requests coming in. So defining that is really important. Couple of points here. I think we should validate the structure, obviously, but we can also validate the content. There are certain fields we might want to go down and make sure we're validating before they get to the database or the back-end API. And we should not forget the metadata. The amount of attacks and issues people have with headers and parameters, whatever protocol you're talking about, can be massive. So making sure you not only validate the message, but the metadata around it is a really important thing. Threat protection. So we have a number of things defined that we know, right? SQL attacks, cross-site scripting, LDAP attacks, all those things are pretty easy for us to detect in messages, but we don't always do that. So validating for threats is a really important thing for us to do. Again, it can be in the payload, it can be parameters and headers, but we should be looking for those threats and stopping them as close to the edge of the network as possible. So doing things like threat protection is really important. Replay attacks for some APIs are vitally important. If you're getting a message that goes through and gives you some important information and then you can send it again and again, you may well be finding you've been exposed. So Stopping replay attacks is really important. And I've got rate limits and quotas here. Rate limits and quotas are often thought about as part of API management, but I think they're a really basic way of securing your API. If you know your back end, your API can handle a certain amount of transactions per second and you built it for that scale, you should be enforcing that further out into the network, either right at the edge or in an API gateway or something like that. So rate limits and quotas are part of the business approach to sharing APIs, setting quotas and service levels, but they can also be a really important part of security. And setting a rate limit can help your API from being squashed or upturned very easily. This is definitely where API security and API management kind of start to blend. You want to know who can share APIs. It's a good idea to have some governance of APIs. There are lots of solutions out there for discovering where your APIs are, and I'm sure everybody that runs those finds APIs they didn't know existed. But it's good to have a standard way of sharing your APIs. They represent your brand and your data, whether they're internal or external. You should be controlling not only who can share them, but who can access them as well. You should be managing them like a product because that's what they are. You wouldn't put a website out there and allow anyone in your organization to put a web page up there with your information and your branding, and you shouldn't you should be putting the same rules in place for your APIs as well. Auditing who is sharing them, who's accessing them, etc. And if possible, you should separate API ownership from API security. If you're treating your API as a product, I'm a product manager, I don't necessarily know a lot about security. The same is true for APIs. If you've got an API product owner, they're unlikely to understand the best way to do security. So separating that out in some sort of API management solution of publishing APIs and enforcing the security rules is a really important thing to think about. The past can equal the present. I almost put this slide because how cool is that car, right? If you can get a car like that and plug it in and charge it, I think you're a pretty cool person. But what I'm talking about here is that you've got APIs from the past. You've got APIs that maybe you inherited. You've got APIs that don't have security or have some ugly security on them, right? Things like Kerberos and WS Security were horrible, but those APIs still exist. That doesn't mean you can't get the value out of them. You can't expose them to your customers and partners. But you should do that in a nice way, right? So being able to transform and modernize your APIs at the edge rather than rewriting the code can be a really, really important thing. And it can protect you from maybe some old security standards that you've got internally or some old message formats that you've got. So think about doing things like transforming a SOAP service, exposing it as REST. You need to get rid of the world of WS Security. You need to get rid of SAML and those kinds of things. So when you're doing that, what you're trying to do is keep the same standards, the same security mechanisms to the outside world, and mapping that to the security on the inside, which doesn't necessarily have all the things you would want if you were exposing it to the outside world. Keep an eye on them. If you've got an API and you're not looking at how it's being used, who's using it, how frequently it's being used, you're missing a whole load of benefits you could be getting. First of all, it's nice to know who's using your API from a business perspective. Is it popular? Is it successful? Are people using your APIs in different ways that you didn't think were possible or you'd not thought about before? Maybe that's a way you can expand your business. But looking at your APIs and monitoring the traffic from a security perspective is also really important. A massive spike in an API usage doesn't necessarily mean a good thing, doesn't necessarily mean a bad thing either, right? Maybe your advertising has worked, maybe the new app is really popular, but maybe it's someone looking at your API, trying to trawl it. Maybe you're looking at not just the request, but the data coming back and forward, right? An API sending back a message of 2, 3, 5K is normal. A response coming back of 100K is a data leak. So being able to monitor your APIs, looking at the usage, the data going through, blocking things like replay attacks is really vital, and it's not something to be overlooked. Okay, don't keep it in. When you use external APIs, the security has to be considered exactly the same as when you're sharing your APIs. And there's a number of reasons for that. Often firewalls, when we do projects in our customers, the firewalls inbound are really hard, right? There's a change control, those kinds of things. The outbound stuff is literally like this fire exit. You open the door, and everyone can just send out API requests to whatever services they want. So as an organization, you have no idea of who is using what API, how they're using it. You're not auditing and logging those things. You're not controlling those things. If you're paying for an external API, something like a Google service or whatever, you've no idea about how to control that, log that, bring that together centrally. So adding some security controls on your outbound API usage is really important. I actually worked with a customer many years ago who was using an external service to look up basically zip code or postal codes and get that information back in. And they had just given access to everybody. We put this in place. We put an outbound security in place. We made sure they were using internal security mechanisms and credentials to get access to that API. We also put things like caching and auditing and logging in there. They saved 6 figures per month from the costs they were actually being charged for the zip code and user login. So it can be a really important way of protecting your company from the API usage that's going outbound. Okay. I feel like I've sped up, but we've got 2 minutes left. This is how we suggest you do it, right? As I said, I don't think there's one size fits all. Layer 7 is at the heart of it, an advanced security gateway. We define policy to do these things. There's some benefits of doing that. You get a standard set of rules across your APIs. You can deploy them across different clouds and different platforms, and you can do some really advanced things in policy. There are obviously other things you need to bring into the space, some of the anomaly detection things, some of the pre-testing, but we recommend using an API security gateway in front of your APIs to be able to do all these things. That helps you with the things like transformation, separation of security from the application itself, standardization of the security rules that you want to put in place. So this is how we do it. We have a multi-platform gateway that can be deployed in a number of ways and scales pretty impressively for a lot of our customers. So what do we need to consider? This is the kind of points I've been through. I think transport is the absolute minimum. You need to have that locked down and tuned to your specific API and your clients as specifically as you can, and have it ready for that flexibility. I think the other one I would put as really important is being able to define the API, defining it with an open API spec or Swagger, doing deep level validation on those things, not forgetting the headers and the headers and the other metadata that are coming in. So they're the things I think you need to consider. Hopefully that was useful, and I'm finishing with about 45 seconds to spare. So thank you very much.